Okay, here we go with the third lesson, the third transformation, which is rotations. This one is probably of the three, the one that people have the most trouble with. It's not hard, it's just a little bit trickier, not a ton. So what is a rotation? A rotation is an isometry. Again, what does that mean? It means the beginning and the end are the same. It's an isometry that turns a figure around a center a certain number of degrees. Okay. Therefore, in a rotation, you need to know a few things. You need to know the center of rotation, which is just a point. You need to know the angle of rotation. We'll talk about that in a little bit. And the orientation of the rotation. Now, there's two orientations. There's clockwise and there's counterclockwise. Now, for this, because you see how long it takes me to write all of this, we'll save you a little time, not a ton. I'm just going to call this counter. Okay, and then clockwise, I'm just going to say CW. Okay. So, the way there, unless stated otherwise, rotations are always, and this is kind of weird to think about, but rotations are always counterclockwise. All right. Okay, that is honestly probably why this is the trickiest of the three, is because you have to remember that if I don't say it, it's counterclockwise, not clockwise. All right, so here we have a regular pentagon. Minimize this a little bit so you can see everything. Okay, I told you it's a regular pentagon, so here we go. What is the center of rotation? That should not be the hard part at all. That is just point O. Okay. If I map A to F, what is the angle of rotation? And I'm talking about the counterclockwise, because that's just the typical way we go, is counterclockwise. Now, what does that mean? It means this way. How far is that? How many degrees? Well, we did this back in area unit when we were doing regular polygons and we found that central angle. We did 360 divided by the number of vertices or number of angles there. And we have 5 angles, so 360 divided by 5 gave me 72. Same thing happens here. So what is the angle of rotation? It's 72 degrees counterclockwise. Now, will rotations always have this degree of rotation? No, it will not. Since the pentagon is regular, though, I kind of already talked about this, the number of degrees between vertices is the same. And in this case, it is 72 degrees. Let's say we had a regular octagon. What would be the angle of rotation? See if you can figure that out. It would be 45 degrees, 360 divided by 8. All right, so now we're talking about the pentagon. Find the image of A when the figure is rotated clockwise, and I did say clockwise here, 144 degrees, about 0.0. Now I just threw in 144 degrees. Just talked about 72, and then I throw a different angle at you. What am I talking about here? Well, what is 144 divided by 72? It's 2. So what I just did there was I did 144 divided by 72. Why 72? Because that's one, that gets me from A to F, or from A to P. It gives me one step from where I'm at. Okay, so 72 is like one step. Well, how many steps do I take? 144 divided by 72 is 2. So I'm taking 2 steps in the clockwise rotation. Now, what's clockwise? Okay, clockwise is this way. So I'm taking A and I'm going 1 step, 2 steps. So I land at point K. That's the image. Find the image of F. Now I'm starting at F. Okay. Starting at F. Might be a good idea to circle where I'm starting. When the figure is rotated 216 degrees, about 0.0. Didn't say a direction. So what am I thinking? This one's talking counterclockwise. So that would be this direction. Well, how many steps am I taking? 216 divided by one step is 72, gives me 3. So I'm going 216 divided by 3, divided by 72 is 3. I go 1 step, 2 steps, 3 steps, and I'm landing at point P. All right. Describe the rotation that would map K to W. Notice I gave you 2 options, and that's because you have clockwise rotation and counterclockwise rotation. Well, the easiest way to get from K to W is to go clockwise, right? It's 1 step. 1 step is 72 degrees clockwise, right? The other way you could go from K to W is 1, 2, 3, 4 steps counterclockwise. Well, what's 4 steps? 1 step is 72 degrees, times that by 4. I get 288 degrees counterclockwise. Okay. Number 6, what is the image of PK? Now I'm talking about a side here. I'm not talking about a vertice or an angle here. I'm talking about a side. PK is that whole thing. What is the image of PK when the figure is rotated 72 degrees, about 0.0? Now again, no orientation given. We're going counterclockwise, which is this way. Now you got to be careful here. I can't just pick 2 points. Well, first of all, it's land. Where we land is 1 step counterclockwise. So I land at AP. And that is the answer here. Now, could I put PA? No, I can't. Because P maps to A and K maps to P. And you have to go in the same order. So AP is the answer here. Okay. Last one. What is the image of W when the figure is rotated 360 degrees, about 0.0? Rotated 360, so that's counterclockwise. So W going counterclockwise. Well, what's 360? How many steps am I taking is what I'm figuring out here. 360 divided by 72 is 5. So I'm taking 5 steps. So to K is 1, P is 2, A is 3, F is 4, 5. I'm right back where I started, which should make sense because going 360 degrees is going in a full circle. Okay. So that was some rotations. One other thing with rotations, and this is a little bit challenging, rotating on the coordinate plane. All right, so rotate the given point 90 degrees about the origin. Now, how do I do that? If I were to draw a line from the point to the origin, go ahead and do that. So the origin again is the center. These 2 lines would be, if I were to draw a line from the point to the origin and another line from the resulting point to the origin, now I don't have that other point yet, so I can't draw that line, so you can't see it, but those 2 lines would be perpendicular. Since the angle formed, I said it here at the beginning, was 90 degrees. Now, what do we know about perpendicular lines? We learned these in Algebra 1. We actually learned them again in geometry back in first semester. What do we know about the slopes of these lines? They are opposite and reciprocal. Of one another. Now, I don't have that second line drawn. Again, I don't have it there, but when I do, those 2 lines are going to have opposite and reciprocal slopes. We can use this idea to find the coordinates of the resulting point after a 90-degree rotation. Okay. What is the slope of the line from the given point to the origin? So that's down 5, right 3. So it's -5/3. What would then be the slope of the line from the resulting point to the origin? Well, it's going to be the opposite and reciprocal. So it's going to be opposite, so it's going to be positive, and the reciprocal is flip that, so it's going to be 3/5. I can use that to get more points. So again, from the origin, I'm going to go 3/5 slope. Okay. Now there is a little bit of a challenge here. So 3/5, so that's up 3, right 5. That gets me here. But I could also go 3/5 and do it again. So, or I could go the other direction. Down 3, left 5. That's also a slope of 3/5. Which one do I want? Now, that's where it comes in. We have to determine which direction we need to go, which orientation we need to go. For this problem, since nothing was stated, we go counterclockwise. What's counterclockwise? This way. So this would be my resulting point as coordinates of, what is that, -5, -3. Okay. So clear that. Oops. Let's say I were to rotate 90 degrees clockwise. That would have been this point here. It should be, oops, nope, not 3/5, 5/3. Now, you might see something like this. Just looking ahead here. What if I wanted to rotate? I just said that that works for 90-degree rotations. What if I want to rotate clockwise 270 degrees? Well, isn't that just the same as 90 degrees counterclockwise? Right? 270 is 3 steps in the clockwise rotation. So if I have this point here, 3 clockwise would be 1, 2, 3. I'd end in this quadrant. A quicker way would be just 90 degrees, 1 step counterclockwise. So 90-degree rotations on a coordinate plane can be kind of hidden by 270 and 180. So steps in the other direction. Okay. That's it for rotations, and that's it for this unit for this year. Unless it's a new year and we're doing dilations. So that's it.